morning and good afternoon, everyone, and thanks for joining this Tech Talk. Today's Tech Talk is motivated by a question that we've had quite a few times, and it usually starts with someone going to the whiteboard and then drawing up something like what you see on the picture here. And the question they ask is, I would like to integrate my PLM system with, and then the question varies a little bit, but it's something like, I would like to integrate my PLM system with our sales configurator, or I would like to integrate our PLM system with a configuration engine, or even better, some might even ask, I would like to integrate our PLM system with the rest of the configuration knowledge we have in our enterprise. Now, as Anya mentioned, I've been working 20+ years with Configit, and I've been involved with quite a few large-scale customer projects. And during that time, I've heard this question quite a few times, but I've also come to realize that there's really not one right answer for that kind of question. So over the next 25 minutes, I will try to summarize how I would approach this question when it's posed to me. So the first thing I would do is I would grab the pen, I would go to the whiteboard, and I would write up 3 things, something like this. So I would start by figuring out, first off, why would we need to integrate the PLM system? I mean, this might sound like a bit of a provocative question. Luckily, it's something that usually have the same answer, no matter who posts the PLM integration question. But the way the answer to why I want to do it is formalized, it tells a lot about where we start from. When we do an integration, we need to know, so what does success look like? What is the success criteria we have? Because we need to be able to measure whether or not we did a successful integration. And finally, we get to the interesting part, which is, so how do we do it? So today is about the why, the what, and the how that we would approach once we get a question like, how do I integrate my PLM system to something? So let's get started with the why. When I ask why, it often starts off with some kind of description of the current systems architecture. So where does the PLM system live, and what is it that we integrate to? And obviously, this system architecture is always a lot more complicated than just 2 boxes on a whiteboard. Typically, the PLM system is the PLM system, but the box with 3 dots is kind of interesting because it says what we want to integrate to. Quite often, people draw a picture that looks a little bit like this. So often we find that we have 3 major systems in play. The PLM system is where we have our engineering intent, but there would also be some customer relation management system or sales system, dealer management system maybe, that talks about how we want to sell products. There would be a manufacturing system that talks about how things are manufactured. And I would say pretty much always we have a plethora of minor systems, which are either bespoke systems, there might be add-ons to the other systems, or there might be just Excel sheets floating around. So the realization that we start with when we post how do we integrate my PLM system is that each of these systems that we're looking at this picture have a piece of the configuration logic in their system. And most often these systems are disconnected. So the logic here we're looking at is kept in silos. And that really means that information in one system is not used by the other systems. So at the end of the day, we have double maintenance, usually contradictory double maintenance. Change management is a bit of a nightmare. It's often erroneous. And at the end, we don't really have an agreement between the systems of what the product we're looking at is. So when we approach this, we would go and say, what you really need is you need to look at your systems differently. We introduce what we call a CLM strategy, which allows us to observe all the available configuration logic we have from the different systems into one combined set of logic. So today's talk is about primarily the PLM system and the CLM system. I will not mention too much the other types of systems in this picture, but just to conclude on this one, at the end of the day, the why do I need to integrate is often caused by we don't have a CLM strategy. Our systems are disconnected. The picture we're looking at here is extremely systems oriented. So it talks about which systems exists. And when I get to the what does success look like and how do we do it, I would like to switch over and think of intent instead. So let's change the picture we have and let's start looking at intent. So what you see here is what we call the CLM circle. So the CLM circle is a way to represent configuration intent of a product through the different life cycles of that product. So if you come from a PLM world, you might look to the upper left corner here and think that's our engineering intent. But as we saw previously, there's configuration intent pretty much everywhere, also on the sales system, the service systems, the manufacturing systems, etc. So this brings us to the what part. What does success look like? So once the systems are integrated, an intent-based view tells us that it doesn't really matter where we keep our logic. What matters is that the logic is consistent. So one of the success criteria we definitely have for this is we need consistency of all configuration logic, no matter which intent we're talking about. And now we can start to think about modeling as a centralized thing, a thing that sits in between all the systems that represents different aspects of our intent. And this actually leads us to the how part. Before I get into that and do all the nitty-gritty details, I'd like to draw a picture in this talk, and for that I would like to put some color coding on the different intent so we can see what is what. So in the following, I'll use yellow to depict something that is engineering intent, blue for sales intent, red for manufacturing, and if we have service intent of products, we would color that gray. I won't talk about service intent, so I only have 25 minutes. So my primary talk is about engineering, sales, and manufacturing. Now let's look at the data for these different pieces of intent. So one way to look at it is we want to build a picture of the data involved that captures all the engineering, the sales, and the manufacturing intent. And I like to draw it like this in boxes on top of each other. So what does success look like? Well, success looks like alignment of all the data that we're going to put in these boxes. So no matter what intent we talk about, all the data we're looking at should be aligned. Another common requirement we hear is that we would like to be able to have a configurator where our customers can go in and specify what requirements they have for the products. So for instance, if I sell wind turbines, my requirement might be about how much power the wind turbine produces. If I'm selling pumps, my requirement might be about what type of liquid and how far that liquid should be elevated when it pumps. So those are requirements that a customer who buys a product would go in and talk about. Now, when the customer communicates with the configurator, all of these requirements comes out as abstractions. So it's very important to note here that these abstractions are not parts. They are what the customer wants for the product. And yet, one of the requirements, one of the success criteria we have for a integration is that even though a customer comes in, do a configuration based on requirements to a product, we still would like to be able to end up with a bill of material which is specific for whatever product has been configured. So to summarize, the success of a success criteria for a good integration of PLM systems into the rest of the enterprise would be alignment of all the data through all the different pieces of intent, and the ability to offer configuration that would lead to bill of materials. Now, of course, there might be other success criteria, but for now, I'll just stick to those two. Okay, this concludes the success criteria. Let's look at the how we do it part. So how will we go about making such an integration? First, let's look at the top. So to drive a configurator, a sales configurator, we need to introduce what we call a product model. So product model, I would also refer to that as a configurable module, is a piece of logic that contains two major parts. It contains features, and features are choices or variants that you can choose from. So I will use in this talk a bike. So when you configure a bike, the choices, the features of a bike when you buy it could be, for instance, what type of bike do I want to buy? What type of user am I? Am I a casual user who just bikes to work? Maybe I'm an amateur who wants to use it for certain competitions, or perhaps I'm a professional bike rider. So these are high-level requirements. Next, when we add configuration logic, we would add rules to these configurable modules. So the rule says which of these features goes together. So basically, the rule says this is the legal variance that we want to sell. Now it's important to note here that the sales and marketing configuration, all the blue sections here, will of course be driven by the sales and marketing intent. So let's put all the definition of those features into the sales area. At the same time, I'll try to build up a picture at the upper left, up here, where I'll put my sales features around the sales intent in our CLM circle. So sales rules are of course authored in the sales system. So we'll take all the sales rules and let's put that into our sales system. Now, next on this picture, we have our bill of material. Bill of materials, they're defined in our PLM or the PDM system. For this talk today, I color my bill of materials red. So don't be confused about that. Usually when you think about bill of materials, you think about the bill of material system, which is often the PLM system. For now, I call it red because what I want to get to ultimately is a bill of material, which is relevant for the configured product. But when I say bill of material, just think about your bill of material system. So what's a bill of material? Well, bill of material basically is a collection of parts and assembly. In our example here, we have a configurable bike, call it bike 2000. And this bike, when we configure it, we would like to be able to build it afterwards. So the bike that we offer will have a corresponding bill of material in our bill of material system. This bike in our example here is composed of other assemblies and other parts. So as you can see here, our bike has a gear system, it has a handlebar, it has a logo sticker, etc. And as we know from traditional bill of materials, they are recursive. So again, the gear system here might contain a rear derailleur. That's the part that moves the chain at the back. It might contain a cassette. That's where the chain runs on all the gears, etc. So bill of material is a fairly known concept. Now, notice in my picture here that I've taken the liberty to have two different types of assemblies. I've drawn some assemblies with a small dash here, and those are standard assemblies as you would know it from a bill of material system. They just say I'm an assembly which consists of other assemblies and other parts. And then I've introduced what I would call variants. It has different names in different PLM systems. But if you look at the rear derailleur, for instance, you'll notice there's a group here called rear derailleur. And each entry in this group is an actual rear derailleur. It's a part. So all the parts are rear derailleurs, but the group, the assembly, the variant up here says, I need one of these. So they represent a collection of parts with the same functionality. Introducing variants is a first move in the direction of making the BOM flexible. And as we will see when we're done, we will have added quite a lot more to the bill of material. So bill of materials, the parts, the assemblies there, of course, they are authored in our bill of material system, which I'll put here at the bottom. So at this point in time, we still have no connection from our sales configurator and all the way down to figuring out how we make a unit BOM. So how will we do that? Well, step one would be to make the BOM configurable. And in order to do that, I would allow the parts to be included or excluded based on the configuration of our product. So BOM configuration is really not, most commonly at least, tied directly up to sales features. BOM is quite technical, while sales features is quite high level. They're about requirements. So in order to communicate, we need to introduce something new. And what we introduce is what I would call technical features. Now, technical features are things which is very specific to the product. In our example here, we have a bicycle. It might sound like a fairly simple thing, but actually there's a lot of features in the bike, which is quite technical that you would never talk to the user about. So one example could be, for instance, the distance between the cogs in the rear cassette, the cog pitch they call, the shift ratio, how much cable is pulled out every time you shift your gear. There might be something about how the front derailleur mounts to the frame. All these are extremely technical and defines how our product is built from a bill of material point of view. Of course, all the technical features, they will go into our engineering intent. Now, in this talk, I will only focus on engineering intent and sales intent. But obviously, as I said previously, there might also be manufacturing intent and service intent. So I would like also to consider that for the future. So we will also have features that represent markets, that represents manufacturing choices or service choices. But right now, it's all about engineering and sales. So this concludes the CLM cycle. Right now, we have a CLM cycle representing the different intents, modeling in the middle, and a feature language that is capable of expressing all the different choices we can have for different intents. So we haven't made the BOM configurable yet. Let's do that. And we do that by adding, some will call it selection conditions, some call it usage statements. We usually like to call it selection rules. So what are these? They are linked to features. So if I look at my rear derailleur that we looked at before, if I want a rear derailleur, I can say I want this specific rear derailleur if I have this technical feature and that technical feature. I might have different choices on the different derailleurs, so I'll use a different rear derailleur if I have that technical feature and that technical feature and one of the other ones. Now, I use this syntax deliberately because we've actually seen the syntax. So if some of you have been working with configurable bill of materials, you might know the syntax. Plus means and, I want two features. A slash means or, and you probably can also do a minus, say I don't want that feature. So when we fill in these selection rules, we would notice that sometimes we actually need to talk about marketing features. It's not just about technical features. For instance, the market might be, the market of where my bike is used might be a selector for something. Now, I did learn that the hard way, ordering a bike on a UK web shop. And what I learned there, that on a UK web shop, or at least in the UK, the gear changes and the brakes are reversed from what I have where I live. So that's a good example where sometimes the requirements of where we want to use our product goes all the way down to the bill of material. Now, the whole bill of material is annotated. We don't need selection conditions on everything, but typically what we do is we add all of these conditions to our parts and assemblies. Of course, we consider the configurable part of bill of material as being part of the bill of material definition. So let's try to zoom in on some of these assemblies we have on the picture here. If I look at the gear system and the handlebar, what I typically want to do is I want to define my technical capabilities of these modules. And what I can do here is I can create a technical model, just like I can create a configuration model for my sales bike. I can create a configuration model for my gear system and for my handlebar. These configuration modules are often linked to the bill of material, the configurable bill of material. So if I have a configurable gear system, I might actually have a configurable gear system module. We build up these modules just like we did if it was a sales module. So that means that we put features in them. And at this point, it's important to note that if we connect a configurable module with the configurable bill of material, the features we have in this module should correspond to the same features we use in the configurable bill of material. So that means when I define my gear system configurable module, I will use the same features in order to select which part goes into my bill of material, my exploded bill of material when I have a gear system. Of course, for this to be configurable, we need more than features, we also need rules. And these are added to the configurable modules here. And what happens now is that an engineer can actually work with modules in isolation. So for instance, we could have one group of engineers that works with gear systems and a different group of engineers that works with handlebars. And the group that works with gear systems could define the features, the rules, and the bill of material in isolation. They can even go in, open the configurable gear system, configure it, and then simulate what happens with the bill of material. So obviously, technical configurations, they belong to the engineering intent. The technical modules here, they define the variance of the product. So they define what is actually technically possible. And now we know we have the blue boxes up here that tells us what is it we want to sell. And we have the yellow boxes here that says what is technical possible. And to answer the how do we get all the way from a requirements-oriented configuration and all the way down to a manufacturing specific BOM for that piece of requirement, we start to connect the dots here. So the first thing we do is we say our sales module will be including our technical module. So when I think of a bike, the way I sell it, I will include my gear system and my handlebar and all the other technical modules that I have. This allows us to have the technical features be part of the configuration. So while the user might only communicate using the sales requirements, the rules in our technical modules will connect the user requirements, the sales requirements, with the technical features, and thus completing the full configuration here. And this allows us to combine a configuration made over sales requirements all the way down to a bill of material which is specific for that configuration. Now the question was, how do I integrate my PLM system? So let's revert the view a little bit and go back to a systems-oriented view. So right now, I will focus on integration of PLM with the CLM system. We will not go into details with where is the ERP system and where are all the other systems. Right now, let's just focus on PLM and CLM. When it comes to integration, we see three main scenarios for how the PLM system and the CLM system could be integrated. So option one would be to say, let's put all the technical information we have into the PLM system. So in this scenario, we will have all the technical features, all the technical rules, and of course, everything to do with bill of material, the parts, and the selection rules. Let's put that into the PLM system. What we do with the CLM system is we add a sales layer on top, sales features and sales rules. Now, if we use this type of integration, what we need to do is we need to make sure that we can push the technical features and the technical rules into the CLM system such that we can create this connection. We can connect the technical modules with the sales module. So that's one option. Another option might be, let's actually go with more information in the CLM system. So in option number two, what we do is that we put all the features and all the rules in the CLM system. We still keep BOM information in PLM, so parts and the selection rules are still kept in the PLM system. But now we have everything to do with features and rules in our CLM system. If we choose this scenario, we need to integrate downwards. We need to integrate such that the features in the CLM system are known by the PLM system, because we need those features when we create the configurable bill of material up here. And finally, we can go, you can say all the way, and have everything to do with configuration logic in the CLM system. So in option number three, we keep our bill of material in the PLM system, the parts and assembly, but all the features, both marketing and technical, all the rules, marketing and technical, and the connection from features to bill of materials could be handled in the CLM system. So here's three different approaches for how to connect a PLM system with a CLM system. Let's try to summarize that. So how do we align a PLM system with the rest of the enterprise? Well, first, we look at the combined product intent, and we make sure that we have all the relevant parties represented: engineering, sales, manufacturing, service, etc. So step one is to create a common language. These are the features that we use in order to define all the intent we have. Now, it's not important where this feature language is defined. What is important is that it's common and it's known to all systems that talk about configuration. So it could be maintained a CLM system, it could be maintained a PLM system, or it could be separate in an Excel sheet for that matter. As long as it's common and known by everyone, we have a common language. The next thing we need to do is we need to define where we put data. So we need to pick one of the scenarios, option 1, 2, or 3, or maybe a variant of that. So with that scenario picked, we know exactly where to put the different pieces of data. And finally, of course, we need to create the data. So we need to make sure that we have all the parts we need. We have a configurable bill of material. We have configurable modules that express our technical intent, and we have a configurable module that express our sales intent. And we need to connect dots. If we do that, then we get to a point where we know that sales and engineering, which is what we're looking at in this talk, that is aligned. And we know that we have a way for creating configurations where we just talk about sales requirements, but that would lead us to the technical features, which enable us to do a bill of material specific for whatever configured product the customer has made. Now, at this point in time, what I've shown you is we have a path where we know we can combine all the different pieces of intent we have. We have a common language, and we have a combination of all our rules. But there might be one question that you are wondering about, and this is a little teaser, because at this point in time, it's not completely obvious that the configurable bill of material we have, this information down here, is truly aligned with our combined rules for sales and engineering. And if you're wondering about that, then I invite you to join the next tech talk, where we will talk about alignment between the bill of material and the rest of the configuration logic. But this picture concludes with offering a way to integrate a PLM system, a way to measure if we reach the kind of integration we want with the success criteria, and it proposes 3 different ways of doing integration. And with that, I think my time is just about up, but we might have time for a few questions.
So one of the questions I have here is, are the challenges when the level of BOM disintegration increases, for example, material, finish, or coating?
Yes, good question. Yeah, so in my presentation here, I can say that I am fairly naive about the BOM, in the sense that I represent it as one big engineering level. But I know from working with bill of materials that there are many levels that you would look at. Often we would look at the bill of material as the parts, and we know when you get down to parts, you might have different variants. So you would have CAD drawings sitting underneath. One example we had from working with a manufacturer of truck systems was that they would look at the upper level of the bill of material as being all the parts and assemblies. And as they drill down, they would get into, for instance, a tank that could sit on the truck, which would have a CAD system that would have a lot of extra variants of that. And you drill down further, it would have different materials, different colors, etc. So I don't have a one answer to combine everything, and I don't think that's usually the intention. But what we learned from that is that the approach of thinking of configurable bill of materials and thinking of configurable modules that drive the configurable bill of materials, that story, that combination can be replicated. So it applies to the different levels of the BOM. How that is done in practice, it depends a lot of the setup of the different PLM systems. So it is definitely an interesting question that I don't have a one specific answer for, but the best I can say is if we can repeat the same process, the same pattern, and apply that through, for instance, the CAD system and the colors, etc., then I believe we do have a viable way forward.
Thank you, that's very insightful. Who is typically responsible for defining technical rules or technical modules?
Yes. So the short answer is that would be people with technical knowledge, because it does require a pretty deep product knowledge. Now, who gets to do that in the company depends a lot on the setup of the company. We have worked with some companies that have a dedicated modeling team. And if you look at the 3 proposed scenarios for integration. Typically, if you go with scenario 2 or 3, those modeling people would work in the CLM system where you have all the rules, and they would be ultimately responsible for both the technical variance and the sales and marketing variance. We've seen other companies that works more engineering based, where all the engineers work in a PLM system. That would be integration scenario number 1. And in that case, you would most often have engineers working on the technical capabilities and a different set of people working on the sales and marketing oriented capabilities. But it all depends on how you look at your product. Some products are driven, you can call them inside out. You define what you can engineer, and then you figure out how to sell it by adding sales configuration. And other companies work much outside in. So you start by figuring out what do I want to define for the market, and then you engineer it afterwards. So that's a choice we have to make. We have to define how do we look at our products, and how do we want our engineers and our sales and marketing people to collaborate.
Great. I think we've got time for just one last question. You've mentioned the 3 different approaches for integrating PLM and CLM, but which one would you recommend?
Yeah, so that depends a lot of the organization of the company. As I just touched upon, if you're very product driven, you usually define your capabilities and add the sales layer later. And for that, you might actually choose approach number 1. Typically what we hear is that engineers who work very deep down on bill of materials and on CAD systems, they like to have everything collected in one system. So the approach you might choose if you're an engineer and you want to be very PLM oriented might be number 1. If you would like to have all your modeling done by a separate group, you might be a company that's driven outside in. So you talk about market intent way before you talk about engineering intent. In that case, you might go with scenario 2 or 3, but it depends on how you want to organize. If you really want to keep everything engineering in one bucket, go with option 1. If you want to keep all your rules and configuration and features in one bucket, go with option 2 and 3.